Photo manipulation is not a new thing. Since the 19th century, in fact, photographers and photography production specialists of various flavors have been using the photographic technologies available to them to adjust and tweak, and in some cases dramatically change, the resultant image in an attempt to correct for imperfections, achieve some more optimal version of reality, or generally mess with the viewer's perception of reality. Joseph Stalin is a famously enthusiastic practitioner of photo manipulation for the purposes of skewing the perception of reality in the viewers of said photos. He had his photo experts remove folks who had fallen out of his favor for one reason or another from photos, including historic photos, so when the new edited photo came to replace the previous one, he could deny that that person was ever in it in the first place. If a photograph could be said to capture reality, then he, Stalin, could change history, and indeed reality, by using these techniques. Stalin wasn't the only historic figure to use photographic technologies for their own self-serving purposes, though. The photographic portrait of Abraham Lincoln, taken by Matthew Brodie, and later used as the basis for the image of Lincoln that would become emblazoned across the US $5 bill, was originally a seated photo, but Lincoln's face was, in post-processing, placed atop former Vice President John C. Calhoun's body, which the photographer had available from another shoot with Calhoun, and which featured Calhoun's body standing next to a writing table, an American flag, and a globe. It was a very presidential-looking setup, and Calhoun's body was very dapperly dressed, so it was decided that Lincoln's head would look better in that image, on that well-dressed and standing body, for posterity's sake. Now, traditional photographic methods gave would-be propagandists and artists and well-meaning family photographers wanting to add a distant relative to an otherwise complete family photo, after shooting both family and absent members separately, plenty of tools with which to accomplish those manipulations. But those tools became more sophisticated, convincing, and intuitive with the introduction of the personal computer, and later with Adobe Photoshop, a piece of software that replicated many of the tools that were traditionally only accessible in the darkroom, putting them on the desktop of anyone with a mouse, a monitor, and a graphics card. Photoshop was originally released in 1990, and it wasn't long before photoshopped became a stand-in term for manipulated images, and the term was often used derisively, indicating that the image was clearly manipulated, either for intentionally humorous purposes or for purposes that weren't meant to be obvious, but which were obvious because of the photoshopper's ineptitude or oversight, an additional arm or leg in a clothing ad, unrealistically neon colors in a sunset photo, things like that. Photoshop made this type of manipulation mainstream, but the advent of smartphones made it common. So common, in fact, that it's more likely that you'll see manipulated photos than non-manipulated photos on some networks. Instagram, for instance, one of the most popular sites, apps, and networks in the world, which focuses on photographs above all else, at least for the time being, allows users to quickly and intuitively apply a variety of filters to the photos they take within the app or which they upload from their device to the app. Instagram was not the first service to offer these sorts of filters, but they popularized them in a way that made them nearly invisible. The idea of uploading a photo that hasn't been quickly retouched in some way, obvious or subtle, is anathema to some internet denizens these days, because of how they are built into the Instagram workflow. It's just understood that the default is a quick adjustment, a quick filtering for flaws in perspective, maybe a little tilt, maybe an adjustment of colors, or more dramatically, maybe adding animal features to one's face, or some kind of augmented reality-style hat, monocle, or other digital accoutrement. It speaks volumes, I think, that the no-filter hashtag is even a thing. The idea being that if you took a photo and uploaded it without applying any filters, that's something worth noting. This is the case because the default for most users is to make at least one adjustment, and usually more than that, to to present what seems to be, for their purposes at least, the best possible version of a photo. And again, this is the same as early photographers would have done in a darkroom, just more powerful and intuitive when compared to what those photographers of old enjoyed. All photos, because of the nature of the craft and the tools involved, are adjusted in some way, whether we're talking about deciding how long to let them develop in a tray of chemicals, or how much we want to tweak the saturation levels on our phones. The main difference is how casually and quickly you can do these things, and to what degree. The new hotness in this space, as of the day I'm recording this at least, is another type of manipulation, which, as I alluded earlier, has been practiced for a long while, but which hasn't been as simple and intuitive as applying a filter until quite recently. Removing someone or something from an image and making that removal feel seamless is something that graphic designers and photographers have generally learned to do early on in their careers because it's long been a bread and butter technique when it comes to photo retouching, whether you're helping remove a sightseer from a photo of the Grand Canyon or removing stray wisps of hair from a fashion photo shoot. Back in my day, when I was first learning design software, this type of work would generally involve stealing a background from another photo from the same photo set with the same landscape, but one which had different people and objects in different places, and then figuring out how to borrow or create elements from the background to swap into the original photo for that object or person that you want to replace. The Photoshop clone stamp tool was also very useful to this end, but different editors had different techniques that worked in different situations. More recent versions of Photoshop, though, can often work through this process automatically. You can select something that you want removed, and the software can figure out what object you're wanting to remove and which pixels represent the background behind that object. And it can then figure out how to fill in the gap left by the removed object, and often with fairly good results. This same process, this sort of tool, was released as an open source project in 2018, leading to a slew of new, interesting websites featuring tools that are accessible free and online, which allow you to upload an image and then edit away those people and objects that you don't want to see. Or in some cases, flipping the script and removing the background instead, leaving those foreground objects intact. This is a really cool and interesting tool to have available, because although we humans are pretty good at distinguishing objects in 3 dimensions and assigning meaning and interest and relationships to those things, software generally has a problem doing the same. What a computer typically sees is not a photo with you and your family in it, with a beach behind you and sand around your feet, but rather a collection of different colored pixels, undifferentiated except for their color, which is why, traditionally, human editors of some kind have been necessary to assign meaning to those pixels, selecting the ones that need to be removed and choosing new pixels to take their place, to fill in the gaps. The technologies that allow this type of software to function are what I want to talk about today. And importantly, I want to address other use cases for this type of technology and talk about what it might mean for our photos, but also for our understanding of the universe, and how we attempt to understand it and everything else in the first place. You are listening to Let's Know Things. I'm Colin Wright. So I have a new ask for you today. If you are enjoying Let's Know Things, this is a very good time to consider becoming a patron on Patreon. I am looking at the future of the show, and I am coming nearer to the end of a speaking tour that I'm currently on. And at the end of that tour, I am looking to double down and reinvest in this show. And the most common request that I have heard from people while traveling around on this tour is that I figure out a way to produce more episodes, which is a very nice thing to hear, but that has been the preference when I've presented different ideas of different things that I might do to expand the brand of Let's Know Things. People generally say they would be most compelled and most interested in getting additional shows as a bonus for being a supporter. So at the moment, if you are a supporter on Patreon, you get a couple of extra little things, and then you also get a call to action free version of the show. So you don't get the little requests to become a patron, and you do not get the additional mentions of my projects and such that I include on this public-facing version of the show. What I am thinking of doing is producing an additional episode each month. So there would be 5 instead of 4 in an average month, and releasing that to my patrons on Patreon. In order to justify that extra time, though, I'm going to need to amplify the amount of support that I'm getting over there as well, the amount of financial support. So what I'm planning to do is start to produce an additional episode each month if we can get up to 200 patrons. And that can be patrons of any level. At the barest level, you can do $1 a month, which is still helpful. It's about 25 cents an episode. Still very much appreciated. The most common and the tier that I'm trying to encourage for most people, if you can afford it, is $4 a month. That amounts to $1 per episode, which hopefully this show feels like it's worth that to you. And hopefully that is something that you can afford to do. It's about a fancy cup of coffee per month. But then some people are also subscribed at the $10 level or higher, which is very much appreciated, and that is the tier at which I'm going to be continuing to introduce additional benefits above and beyond that extra episode. At the moment, I'm sending out postcards to people from my different tour locations each month who are subscribed at that level, and I will continue to mix that up and introduce what I think will be fun and interesting things. But the idea here is that I would love to produce more of this show. It actually takes a great deal of time and effort to produce, though. So before I can start producing another one each month, I will need to get up to around 200 subscribers. So if you have been waiting to do so, now would be a great time to pull the trigger on that. And of course, the more revenue that I'm able to bring in each month through this project, the more time I will be able to commit to it over time. So I definitely don't want this to seem like some kind of money grab. I'm going to continue to produce the episode each week that I am producing today. But if that is something that sounds interesting to you, just another episode like any other episode each month, made available to you and to other patrons, consider becoming a patron at patreon.com/letsknowthings. And a great big thanks to everybody who is already supporting the show in some way, including on Patreon. Your support really does make all the difference, and you are the reason I've been able to continue producing this show at this scale for nearly 3 years already. So thank you very much for that. I really love being able to work on this show each week. All right, let's get back to the show. Before we really dig in to this episode, a quick note about artificial intelligence, which I try to note anytime I bring up the concept on this show. AI is a term broadly applied to a variety of different techniques, many of which involve something that we might loosely call learning, none of which, currently at least, have allowed us to create what's usually called general intelligence, which is something like what we have as humans, a flexible sort of intelligence that somehow, perhaps emergently, leads to what we often describe as consciousness, despite our lack of agreement about what that word means specifically and how to describe it scientifically. So when you see the terms AI or artificial intelligence used in the news, it could mean a large number of different things. But when I use it in this episode, I'm referring to a very specific set of computational techniques. And more specifically, in this episode, I am focusing almost entirely on a type of machine learning called Generative Adversarial Networks, or GANs. Machine learning is a type of AI research that involves using algorithms and statistical models to generate a collection of what's usually called training data, which it can then use to make assumptions about how to refine itself over time, to perform a set task better and better based on what it learns from that collection of data. A GAN, then, which again stands for Generative Adversarial Network, makes use of 2 types of artificial neural network, which is a term for a network of nodes that operates a bit like a human brain, which is made up of non-artificial neural networks, networks of neurons. But when computers do the same, they operate on superficially similar principles, in that you have an input layer of information, a layer where the nodes perform some kind of task, some kind of computation. and then an output layer of information, derived from that computational layer. But these two things, the natural and the artificial neural networks, are still quite different. The important thing to note here, though, is that a neural network works kinda sorta like a brain, but not really. An example of this type of computation might be taking a set of data, looking for similarities between some of the data points in that data set, and then outputting newly organized and perhaps even labeled data points. And that's more or less one of the functions of a generative adversarial network. Though, as is implied by the name, there are actually two types of processing happening here. And those two separate components are set up as adversaries to compete with each other in a context that results in useful outcomes for the folks who utilize GANs for various purposes. That, I think, is a decent, super quick primer for what I want to get into next. The article that I'd like to start with today comes from Quanta magazine, and it's entitled How Artificial Intelligence is Changing Science. I've spoken before on this podcast, almost certainly more than once actually, and from slightly different angles, about the issues that we all face today to varying degrees, because we live in a world in which the amount of information being generated and delivered to us on a daily basis through a variety of mediums and vehicles is increasing a lot more rapidly than our ability to filter and parse that information. This is a problem that science and the many subfields and industries that fall under that larger header are facing as well. And in an effort to deal with all that data, to try to derive meaning from it, rather than drowning in it, the way that some of us individuals are drowning in information and media, I think, some researchers are changing their approach to doing science to see if they might utilize that data tide and harness it rather than suffering from it. And some of those who have shifted their stance in that direction have come to the realization that it may be prudent to change their entire approach to science, including aspects of the scientific method, as a consequence. This piece from Quanta magazine gets into the weeds on that topic, discussing some of the issues that are currently being faced by scientists working in different fields, but also some of the rewards of taking a new approach, and some of the problems that might be faced as a consequence of changing research tact. There are also some concerns about what might happen if a change is made, or made too quickly, and what it might mean for our perception of science, and the role of scientists moving forward. And it does this, in part, by looking at GANs, at those generative adversarial networks that I mentioned a few moments ago, and how they are being used to do research these days. So GANs pit two different artificial neural networks against each other in a zero-sum game. So there's just one winner and one loser, and they understand this. Those are the parameters under which they are operating. Generally, one of these networks is what's called a generative network, and the other is a discriminative network. The generative network's job is to create noise, and then refine that noise into something more specific over time, reshaping it into increasingly recognizable shapes, for instance, in the case of a GAN that is dealing with some kind of image, some kind of graphic. The discriminative network's task is to look at the images created by the generative network and see if they fit into a category provided to the GAN by the user. And that category is often described not by giving the discriminative network a set of instructions, but instead by giving it a set of training data. So if you want to train it to recognize cats, you give it a lot of images of cats, perhaps even millions of images of cats, and it looks at those images and tries to figure out what they all have in common. And then when the generative network gives it new, original, noise-based images, the discriminative network tells it yes or no, that is or that is not a cat. Over time, and this happens very rapidly, over and over and over again, because these two networks are interacting with each other at the speed of computation, not the speed of a person handing another person a photo. Over time, the generative network's random images start to look more and more like cats, because the discriminative network shows it what it is looking for by picking out cat-like details that seem to be in the proper arrangement and saying, yeah, that could kind of be kind of like a cat, and that leads to more cat-like noise, which eventually becomes a cat-like image. In turn, the generative network teaches the discriminative network to be more and more specific by sometimes tricking it into thinking some lump of nonsense pixels is a cat. That's its entire goal in life, to trick the discriminative network, just as it is the discriminative network's lot in life to not let any non-cat images through. So the two networks operating in opposition to each other, each winning or losing according to their specific set of standards, will over time train the GAN that they are a part of to be really, really good at recognizing cats. And also, should they so choose, or rather should the user of the GAN so choose, they can train the GAN to make new, original cat images out of nothing, out of essentially random noise. This type of use case, although it's just one imagined example of what you can do with this type of GAN AI software, is actually already being used for similar things. All sorts of similar things, actually. You may have seen the website that generates new random fake human faces every time you reload the page. If not, I will link to it and other sites like it in the show notes. But if you haven't seen it, the faces are quite convincing. And those faces are generated by GANs that use a library full of human faces to figure out what human faces are like. And it then produces new faces out of noise. And many of these faces are so super realistic and convincing that you could be forgiven for not realizing that they are not just stock photos. They're not real people. They are the GAN's idea of what human faces look like. You can also generate cartoons from scribbles that you make on a page. You can create original machine-generated anime characters. You can even create new fonts, new graffiti, stuff that no human has made, not in the traditional way, anyway. All of which were created by machines using this GAN method instead. And yes, you can also create GAN-generated cats if you so desire. Check the show notes for that link as well. Now, there are different permutations of this same GAN process, involving different intended outputs, different inputs, and different knowns and unknowns on either side of the GAN equation. The outcome, though, is almost always a piece of software that is very good at, quote-unquote, knowing, by some definition of that term at least, a lot about what makes something what it is, what makes a cat, what makes a car, what makes a human face, and so on. And again, this capability can be used to create completely original anime characters. It can be used to create new works of art in the style of an existing artist. It can be used to recognize cancerous moles in a photo of a patient's skin. You can also use this technique to recognize spam emails from non-spam emails, to determine an age of a person in a photo based on the lines on their face and other visual indicators, and even to construct 3D models of objects from 2D images of that object, and, using the same premise, to upscale low-resolution video game graphics into higher-res versions of the same. You can input a bunch of screenshots from that game, and you stand a good chance of being able to build your own new pixel-dense renderings of those digital assets, even if you don't have the original wireframes constructed by the developer. This article primarily focuses on another use case for GANs that could be even more fundamental and paradigm-shifting, though. And that's the use of this technique to do brute force research, churning our way through potential outcomes and variables and data points, allowing us to feed massive data sets to these sorts of systems, and then receive an answer automatically after they do their thing. This process was used during a scientific investigation, which was written about in a paper that was published in December of 2018, in which the scientists involved were trying to figure out what changes galaxies undergo as they age. The idea was to train the discriminatory network using images of galaxies, and then allowing the GAN to show the researchers what attributes are found in galaxies of different ages. And to do this, they were forced, in some ways, to temporarily ignore everything else that they'd learned about the subject, to allow the system to find what it could, unbiased as possible, by existing scientific knowledge. The outcome of this particular tech/science adventure was that the lead scientist on the project was able to utilize what he called a, quote, hypothesis generation machine, end quote, to help them find next step research targets and derive new meaning and new potential testable hypotheses from existing collections of data. Importantly, and this is a point made by that same scientist, what comes next has not been automated in the same way as that one part of this process. From the article, quoting that scientist, quote, I have to come in as a human and say, okay, what kind of physics could explain this effect? End quote. But all the same, this approach could dramatically influence the early stages of scientific inquiry. In particular, it can tell scientists where they should be looking in the first place, giving an indication of how things are so that they can spend more time figuring out explanations, rather than trying to make observations that they might someday test. In other words, it kind of systematizes some portions of the scientific process, including many that are typically the biggest slogs for the humans involved. And that's very interesting, and it could potentially change a lot of things, both for better and for worse. It does maybe help us get a better grasp on what we should be testing sooner. It could give us more refined data to work with when deciding what does what and how. It also might provide us with a third way to approach science, the first two being observation and simulation, and this new one being data-derived implication. What this means for scientists is currently up for debate, and rightfully so. It could be that our approach to science, in many spaces at least, recalibrate to favor this method of testing, which involves making as few upfront assumptions as possible, and instead allowing the crunching of these big data sets to tell us where to aim our brains and other tools. That's a huge shift from how we do things now, but it's possible that some fields could move almost entirely in this direction, especially fields like astrobiology, where it's difficult to set up useful simulations, as much of what we know, or think we know, are assumptions based on other assumptions. GAN network-based leads of this kind could put us on firmer footing from earlier on in the process. Almost certainly, though, at least for the foreseeable future, this will just be one more tool in the scientists' tool belt, giving them the ability to make their own hypotheses and simulations, and then allowing them to test those ideas against the outcomes of well-constructed GAN-related outputs. In other words, science as usual, but with a mechanism for testing assumptions along the way, which could help those involved tweak their settings or even their hypotheses earlier and more frequently, making valuable and accurate outcomes more common. There are some science world forecasters, though, who are concerned that this iteration might actually be a negative evolution, something that could dramatically change the way that we look at the world and perceive our role in assessing that world. Might it be that we will so inextricably integrate this method, or something like it, into our scientific process, that we'll become dependent on it, that our critical capabilities might atrophy in favor of reading a machine's output? Might we become better rote coders and far weaker imaginative critical scientists? It's possible. It's especially possible if the hits keep coming and this technique continues to prove its utility in a variety of circumstances, a large number of industries, and for a whole slew of intended outcomes. It's looking increasingly likely that the next round of antibiotics, of disease cures, of food flavorings, of material science, and even written work could be generated using this sort of model. Maybe not specifically a GAN, at least as we build them today, but something quite like it, a GAN cousin, or a descendant perhaps. It could be that, even though this model isn't ideal for everything, it's ideal for enough, for 80% of what we want to do, and perhaps even the most profitable segments of science and technology and media, so that the incentives nudge the next generation of people working in these fields to focus on GAN generative science and GAN generative media, rather than the alternatives, the more traditional resource and effort involved stuff. That could be a tough moment. Tough because we might atrophy, we might lose skills that we actually really need, even with these new tools available, but also because of what it could mean for us culturally, self-perceptually. There was a piece written about this potential of changeover recently, which bears a headline that I think captures this difficult moment perfectly. That headline is, quote, "When the invention becomes the inventor," end quote. The cultural struggle here might revolve around the process of discovery and the refinement of our methods of pursuing knowledge, but it could also be something a little more fundamental, the idea of being replaced. And not even by a perceived equal, but by our own creations. This might manifest as a kind of indefinable sense of lost utility, of lost prestige, and it's perhaps not something anyone would want to outwardly acknowledge or even talk about, because it seems a little petty or even selfish, doesn't it? The idea of being jealous of your kid, or of people from a country that you and your country did your best to help out at some point in history. The idea that those people, those entities surpassing you in some way feels wrong, feels bad, that seems trivial, but it's something that some people do feel. It also could be a bit like other cases where a technological shift occurs and some new whiz-bang gizmo comes along, destroying an entire industry in the process. A lot of these sorts of consequences are inherently unequal in their application. They're good for some and bad for others. Good for the users of the newfangled telephone and bad for the telegraph operators who are out of a job and maybe even a career. The revolution, if that's what's really happening here, has not arrived yet. These are early steps with a lot of potential, but the grand span of possibilities isn't clear yet, even if we have theories and maybes to dream about and worry about. One of the primary benefits we could see here, though, in my mind at least, is the amplification of our cybernetic, cyborg capabilities, our ability to use increasingly powerful tools to inform our own human-style decision-making and imagining, which in turn makes both the computer-generated information and the human-style decision-making and imagining more powerful due to that beneficial combination. And who knows, maybe addressing our self-consciousness in this space about this topic will allow us to move in new positive directions in the future. Maybe we need to get over ourselves and foist some types of responsibility onto our creations, because our brains, our biological capabilities, are better utilized elsewhere. Or maybe it'll be our self-consciousness that shows us where the cliff edge is, so we can step back from the precipice before doing something harmful to ourselves or to the world, losing something innate and valuable in exchange for something easier but less valuable. Just as we're seeing with other use cases and other types of AI, there are a lot of considerations we'll need to keep in mind as we begin to mass produce knowledge and mass process data that has been, thus far, filtered and utilized quite sluggishly. That drudgery, perhaps somehow vital to the scientific process, but perhaps not. Perhaps something that is worth discarding in favor of some new setup that is only now coming into view. Most likely, there will be pros and cons to speeding things up. But ideally, as we do so, with each decision and each new opportunity, we'll consider the consequences, primary, secondary, tertiary, and beyond, of both the new tool, the new process itself, and all the ripples that implementation of it will send through society. Not just other fields, but the way that we interact with each other, see the world, and see ourselves as well. So as I mentioned in the intro, I am hoping to move toward a situation where I can start producing an additional episode of this show each month. So 5 shows instead of 4 in a normal month. And that extra episode will be available to anybody who is a patron on Patreon. Before I'm able to make that additional investment of time and energy, though, I am hoping to get up to 200 patrons on the Let's Note Things Patreon page. They're currently somewhere in the neighborhood of 130. So if you have been waiting on that decision to begin supporting this show financially in some way, it doesn't have to be a great big contribution. It can be something like $1 or $4 a month. 25 cents or $1 an episode respectively. You can also commit to a higher tier, which is very much appreciated as well, and I will continue to find interesting ways to reward the folks at that tier for giving a little something extra. Whatever the case may be, once we get up to 200 patrons, I will begin to produce an additional episode per month that will be available to all patrons for the show, and I would love to be able to start doing that sooner rather than later. So if you are keen to help make that happen, pop on over to patreon.com/letsnothings. The book that I'd like to recommend today is one that I'd been meaning to get around to for ages and only just recently read for some reason. I'm not sure why this kept slipping down lower on my reading list, but it did. And the book is called Accelerando by the author Charles Stross. And this is technically a collection of short stories. They go chronologically, though, so it kind of feels like a continuous book in certain respects. But it features a collection of very interesting characters from a moment just before a singularity, a technological singularity, through that singularity, and coming out the other side of that singularity. And the characters themselves are quite interesting, but the world that they exist in and the way that that world changes is the real feature here. And the collection of technologies mentioned and the cultural shifts that occur within this book are themselves worth the price of admission. So if that sounds interesting to you, consider picking up a copy of Accelerando by Charles Stross. You can find out more about me and my work at colin.io. You can find the show notes for this episode and every episode of this podcast at letsknowthings.com. You can find my blog at exilelifestyle.com, my tour dates for the tour that I'm currently on at becomingtour.com, and you can find my advice column about life at somethoughtsoboutliving.com. Feel free to reach out and say howdy on your social network of choice. I am at Colin is my name on most of them. Thank you so very much for listening. I am Colin Wright, and I will talk to you again next week.